Hello guys, in this session I am going to discuss some of the problems from chapter 2 of this book Engineering Circuit Analysis by Hayt and Kemmerly. So the first problem that I have taken is this. Over here it is given in the question that the total charge is expressed as 5e power minus t by 2 where t is expressed in seconds and we need to determine the current flowing through the device. We also need to draw the waveform of qt and it. So first of all, let's determine the current. So for determining the current, we know that the relation is dq by dt, and means whatever expression over here, whatever expression of qt is given, we simply need to differentiate it. So differentiating this, we know that it will be right. So this will be our it, right? As we know over here, we know that when we have this exponential term, so first of all, a differentiation of et, it is exactly same as e power t, and after that in the power we have this minus t by 2, right? So minus t by 2, after differentiating this we will differentiate minus t by 2, so differentiation of it is minus 2. So I put this expression, and this can be written as this. So it is not plus, it is minus, it is minus 5 by 2 e raised to the power minus t by 2. Now once we get it, now the next task is to draw the waveform. So if I want to draw the waveform of this qt versus time, then we know that e raised to the power t, we have two type of graphs. One graph, it is exponential rise, another graph, it is exponential decay with respect to time. It is exponential decay. This is t. Let it be yt, let it be yt, right? So out of this, which one graph, which of these two graph, like which one is of the e power minus t? So to determine this, what we are going to do, we are going to substitute the value of t. Like we have two things, either this can be the graph of e power minus t, or this can be the graph of e power minus t. So what I am going to do, if I have this e power minus t by 2, so what I am going to do, I will substitute the value of t equals to infinity, and I will check that what will be the value of this at t equals to infinity. So substituting this, I will get infinity by 2 means e power minus infinity means 1 upon e power infinity, and it means that I will get 1 upon infinity, which is equal to 0. So you can see that over here, we get this as 0, and this 0 means that at t equals to infinity, means t tends to infinity, our value should become 0. So this is the graph, this second one, it is the graph of e power minus t, or we can say power t by 2 minus t by 2. So when we need to draw the graph of this qt which contain this e power minus t by 2, so my graph, it will be simply this, right? And now over here I also need to put what is the value over here, then only my graph will be complete. So over here at this location t is equals to 0. So what I am going to do, that I am going to substitute t equals to 0 in this expression. Means we know qt is equals to 5 e power minus t by 2. So I will substitute the value of t as 0, so I will get e power 0, so which is 5. So it means that this is 5. So this is the graph of qt, and similarly I can draw the graph of the it. So to draw the it, let me draw it over here. So if I draw the graph of IT, and this is T. Now since I know that in IT it is expression is minus 5 by 2, expression is minus minus 5 by 2, right? It means our graph, it will be something like this. Okay, so because again if I substitute t equals to infinity over here, then I will get 0. It means our graph will end at 0, right? And since it is negative, so it is coming from the negative value of IT, and over here it will cut at minus 5 by 2. Means we will again substitute the value of t as 0 over here, and we will get minus 5 by 2 e power 0, which is minus 5 by 2. So this is the graph of IT. Now coming to the next question. If I come to this part, the second question, in this second question it is given a new type of device appear to accumulate charge according to the expression qt. So again qt is given, and over here it is asking that in the interval 0 to 5, at what time does the current flowing into the device is equal to 0. So we need to determine the time at which the current is 0. So to determine this, again what we are going to do, first we are going to determine the IT, which is expressed as dq by dt. So again we are going to differentiate this equation, which is 10t square minus 22, and it is millicoulombs. So it means that we are going to get the answer in milliamperes, right? So differentiating this, we get 20t minus, it is 22t, so minus 22 milliampere. So this is the current, right? And the A part, it is asking we need to determine the time at which current is 0. So if our IT, when we get IT is equals to 20t minus 22, right? So we need to determine the time when it is 0. It means we get this equation, and solving this equation we get 20t is equals to 22. So the time is 22 by 10 second. So at time 22 by 10 means, sorry, 22 by 20, so it means 11 by 10, that is 1.1 second. So at time 1.1 second we will get current as 0. And now the second part says that we need to sketch a qt and it. Now over here this expression is little bit complex, so how to draw it? So there are different ways, like so over here what we can do, because we just need to draw the rough sketch. So what we can do, simply I will take different value of t and corresponding value of q, and similarly corresponding value of I, right? And since I need to plot in from 0 to 5, so what I can do, I can take different values, 0, 1, 2, 3, 4 and 5. We can also take values in point, like after 0 we can take 0.5, then 1, then 1.5, then 2, means at the interval of 0.5. But just to solve it in more easier way, so I am taking only these values. So at t equals to 0, our q, if I substitute t equals to 0 over here, so our q, it will be 0, right? If I substitute 1 over here, then it is 10 power 10 into 1 raised to the power 1, which is 10 minus 22, so it is minus 12. Then t equals to 2, I will get value 10 into 2 raised to the power 2 minus 22 into 2, which is 40 minus 44, so it is minus 4, right? After that, when it is 3, so 3 square, so it is, we get 90 minus 66, so 90 minus 66, and we get 24. After that, when it is 4, so when it is 4, so it is 4 square 4, so 160 minus, and this is 88, so we get 188, so 72, and the last is 55, 5 square 5, so this 5 square is 25, so 250 minus, and 22 into 5 it is this, so it will give us 140, right? And similarly I can determine the value of I by substituting the value in this equation, right? So at t equals to 0 I get I as 22, then t equals to 1 I get minus 2, then t equals to 2 I get 40 minus 22, it is 18, then t equals to 3, 60 minus 22 I will get 30, then t equals to 4, 80 minus 22 I will get 58, and then t equals to 5, 100 minus 22 I will get 78. And now once I get these values, then I can draw the values on the graph. So if this is t, this is q, so you can see from the qt graph, you can see if I take the difference of this, so over here the difference is of 12, means from 0 it is going downward, right? After that from minus 12 to 4, minus 12 to minus 4, so it means it has increased by 8, minus 4, then minus 4 to 24, so now it has increased to 26, 24 to 72, means now it has increased with 48, and now 72 to 140, so it has increased with 68. So you can see that initially it go down, but then it start increasing. So means if we draw a graph like this, it is 1 2 3 4 and 5, so our first q is at t equals to 0 we have this, at t equals to 1 we have minus 12, so let it be over here, at then it is at 2 it is minus 4 minus 12, then t equals to 3 it is 24, so it will be somewhat over here, right? T equals to 4 it will be somewhat over here, right? And t equals to 5 it is 140, so it will be somewhere over here. So we are getting a graph somewhat like this. So this is the graph of qt. And similarly, if I draw the graph of it, then at t, first I will put this marks, it is 1 2 3 4 and 5, and then if I draw a graph over here, then it will be at t equals to 0 we have minus 22, at t equals to 1 we have minus 2, at t equals to 2 we have 18, so it will be this, t equals to 3 we have 38, then 58, and then 78. And if you look at a difference, so the difference over here minus 22 to minus 2 difference is 20, then minus 2 to 18 difference is 20, 18 to 38 difference is 20, 38 to 58 difference is 20, 58 to 78 difference is 20. So since the difference remains 20, so it is going to be a straight line, right? This straight line we can also determine because this equation is just a linear equation, right? So we can, in fact we can, instead of drawing this, we can also simply get 2 points, one at t equals to 0 and second point at I equals to 0, and from that 2 points we can easily get this straight line. So in this way we can draw these two curves. Now coming to the third question. In the third question, it is given that this waveform, current waveform is given over here, and for a period of 4 seconds. Now it is characterized by a period of 4 seconds. It means that after 4 seconds it is going to repeat itself. So the time period, it is the time period, that capital T, it is 4 seconds. And you can see that after 4, now the waveform is repeating itself, right? So now the question that is asked is, what is the average value of the current over a single period? Means from 0 to 4 seconds, what is the average value? And when we are calculating the average value, especially from the graph, then simply we need to determine the area under the curve. And if you look at the area under the curve, then this area, the height is 3, and this length is 1. So this is 3 into 1. Now coming to the second part, this one. Now this value is -1, and this is distance, it is 1, because the timing distance is from 1 to 2. So the area, it will be taken as plus -1 into 1. Remember, we need to take it as negative, right? So in average we need to take it as negative. Now coming to the third part, means this part. So over here again this distance is 1 and the height is 1. So again plus 1 into 1. And the last one, this one, over here it is 0. So we will get 0 into 1, because distance is 1, right? Now area, because we need to calculate the area. So this area under the curve divided by total length, means the time is 4. So we are going to divide it by 4, and this will give me the average value of current, which is equals to this 3 minus 1 plus 1 plus 0 upon 4, and which is 3 by 4, and it is 0.75 ampere, right? So this is the answer to the first question. Now second part says compute the average current over the interval 1 is to 3, from 1 to 3. So in second part again we will follow the same thing, but only thing is that we are not going to include this, because it is this part is from 3 to 4, right? And since we need to calculate the average only from 1 to 3, so it means that we are going to calculate the average value only for this part, and for this part from 1, in between 1 and 3, you can see that from time 1 to 2, so 1 less than t less than 2, the current is -1, and from 2 to 3 current is 1. So you can see that over here for this part area is -1 into 1, and for this part area is 1 into 1, and it is -1, it is 1. So when we add these two, -1 plus 1 divide by 2, we get 0.2, which is 0 ampere. So the average current over this interval, it will be 0. Now coming to the third part, over here it is saying that if QC is equals to 1 second, then we need to sketch the QT. Now over here, how we can sketch QT? Now for this graph, let me erase this. Okay, so for the C part, where we need to plot the graph for QT for the interval from 0 to 4, right? So we know that IT is the differentiation, I is equals to dq by dt. So following this, we can say that Q will be the integration of I dt, right? Or we can say Q is equals to IT plus C. where c is the constant that we need to determine. It is also given in the question that q0 means the charge at t equals to 0, it is 1 coulomb. So what we are going to do, first we are going to determine for t for this range. For this range we are going to determine the q. So qt is equals to it plus c1. Now to get the to get the expression over here, what is t? Our t, it will be 1. It will be 1, as if we integrate, if we do this integration, for the range 0 to 1, so we will get dt. It will be like sorry, if we do the integration I dt, then we will get the answer as it, and the range is this 1 and 0, and substituting the value of t over here, so we get I minus 0, means it is I, right? It is I. So over here, what, or simply we can say, instead of doing this integration, simply we will write this it plus c1, and we need to determine the value of c1 over here. So to determine the value of c1, what we are going to do, we know that it is given that at t equals to 0, q is 1, right? So we are going to put q0 is equals to 1, which is given, into I into 0 plus c1. So from here we will get that c1 is equals to 1, right? So it means that for this range, our qt, it is equals to it plus 1, right? Similarly, we will determine for range 1 to 2. So for 1 to 2, again we are going to write this equation it plus c2, and over here we need to determine the c2. But from the previous equation, we know that this equation is valid also for t equals to 1, right? So from this equation we can determine what is the value of q at 1. So what will be the value of q at 1? It will be q1 equals to 1 into I plus 1 I into 1 plus c2. Over here I is, we can, if we look at a graph at t equals to 1, I is 3, right? So this will become 3 plus c2, and q1, sorry, it is not c2. If we substitute t equals to 1 over here, or simply what we can do, over here I, we can put the value of I as 3 over here, because in the interval from 0 to 1 I is 3. So simply we can put it as 3t plus 1. So our equation will become this. Now if I substitute, if in this equation, if I substitute the value of t as 1, then I will get 3 into 1 plus 1, which is 4. So I get what is the value of q1, which is 4. Now substituting this value, if I put q1 over here, which is 4, which I get from here, which is, and equals to it plus c2, right? Now over here t will be replaced with 1, right? So 4 equals to I plus c2. Now what is I? If I again look at a graph, so in between 1 and 2, I is minus 1. So simply I will put I as minus 1. So it is 4 equals to minus 1 plus c2. So I will get c2 is equals to 5, right? c2 is equals to 5. So our equation, this equation will become qt is equals to it plus 5, and over here since I is minus 1, so it will become minus t plus 5. So this is the equation for range 1 to 2. Similarly, we will determine for 2 to 3. So over here again our equation, it will be qt equals to it plus c2. We know that from this equation we get at q equals to 2. At q equals to 2 we get minus 2 plus 5, which is 3, right? Now from this equation, means for this interval, we will put q2, which is 3, and it is equals to I into 2 plus c2. Now in this range, if I look at a graph, so in from 2 to 3 the amplitude is 1, so it means I is 1. So I can put this 3 1 into 2 plus c2, or let me take it as c3. So 3 equals to 2 plus c3, it means c3 it is equals to 1, right? So substituting this value over here and I as 1, so I will get qt is equals to it plus 1, or qt it is equals to t plus 1. So this is the equation for interval 2 to 3. And now the last one for the range 3 to 4. Again my equation will be qt equals to it plus c4. Now in between range, for the range, sorry, let me zoom down the things. Okay, so at 3 equals to 4 the amplitude is 0, so it means for this range this I will be 0. It means that our qt it is equals to c4, and at from this equation we can see that at q3 it will be 3 plus 1, which is 4, right? And substituting this value over here, q3 equals to c4, which is equals to 4, so we get c4 equals to 4, and hence our qt is equals to 4 for this range. And once we get these 4 equations for 4 intervals, means I get the equation for range 0 to t, I get this. For range this I get this. For range this I get this, and for this I get this. So now I need to plot the graph. How I am going to plot the graph? Let me plot it over here. So 1 2 3 4. Now from 0 to 1, I need to look what is the equation of the qt. Equation is 3t plus 1, means at t equals to 0, if I put t equals to 0 I will get 4. So at t equals to 0 my amplitude it is 4, and at t equals to 1, if I put t equals to 1 in this equation, okay, at t equals to 0 it is 1, and t equals to 1 it is 4. right? So it means at t equal to 0 it is 1 and t equals to it is 4. So our graph, it will be like this between 0 to 1. After that, between 1 to 2, the equation is minus t plus 5, right? So if I put the value, if I find q1, you will find, substituting the value of 1 over here, I get minus 1 plus 5 equals to 4, which is same as we get from this equation, right, for this range. So it is same. And now if I put q equals to 2, I will get minus 2 plus 5, which is equals to 3. So it means at 2 it is 3. So at 2 it is 3, means our graph, it will come like this. Then coming to range from 2 to 3, if I put the value q2, then I will get 2 plus 1, which is 3, which is same as we already obtained. This is 3, this is. Now coming to the next question. So over here we need to determine the power absorbed by each element in A, B and C. So we know that if we have any object, any component, if we have any component and over here we have plus, we have minus, and if the current is entering through the positive terminal, then it means that it is absorbing power absorber, and the power absorbed, it will be V into I if this is V, right? And if we also know that if it is leaving the positive terminal, if the current is leaving the positive terminal, then it means that this particular element, it is a power supplier. And if, like in the question, it is asked that we need to determine power absorbed, so if the element is power supplier, then in that case simply we are going to put a minus sign, right? So coming to the first one, over here it is given 6 volt, it is given current is 1 picoampere. So our power, it will be VI. So it will be 6 into 1, which is 6 picowatt. Now we need to put a sign, plus or minus. Plus if this element is an absorber, minus if this element is a supplier. So now since this current is entering the positive terminal, so it means that it is a power absorber as per this. So the answer for the first part, it is 6 picowatt. Now coming to the second one, again we determine power, which is V into I, and over here it is 1 into 10, which is 10 milliwatt, but plus or minus. Now again, since the current direction is this, it means it is entering the positive terminal, so it means it is positive, right? So again, it is the absorber and the power absorbed is 10 milliwatt. Now coming to the C part, over here you can see that the current is entering the negative terminal, and current entering the negative terminal means that the current is leaving the positive terminal. Since it is leaving the positive terminal, so it must be the supplier as per this. So the power will be VI, which is 10 into 2, which is 20. But since it is a supplier, so it means that it is minus 20 watt. Now coming to this question, determine the power supplied by the leftmost element, which is leftmost element is this. Again, power is VI, which is 2 into 2, which is 4. But again, over here it is asking power supplied. Now over here, since the current is leaving the positive terminal, and we have learned above that if the current is entering the positive terminal, then it is absorber. If it is leaving the positive terminal, then it is a supplier. So over here, since it is asked power supplied and the current is leaving the positive terminal, so it means the answer will be plus 4 watt. Means this device, it is supplying the power of 4 watt. Coming to this question, like over here this graph is given, and it is asked that we need to determine the value of short circuit current. Now we know that if there is a short circuit, like short circuit means, suppose if we have this type VR, and this are the two terminals A and B. Now if these two terminals, if it is short circuited, if it is short circuited, so it means that in the short circuit current will be there, but there will be no voltage drop because there is no element present in the short circuit part, so the voltage will be zero. And so from the graph we will check the location where the voltage is zero, so voltage is zero over here, so corresponding to this we will determine the current, which is 3. So the value of short circuit current, it is 3 ampere. Now the what is the value of the voltage at open circuit? At open circuit means this, right? Means there is no wire connecting the A and B, and if there is no wire, it means current will be zero, and we need to determine the voltage. So over here in the from the graph we need to determine the location where the current is zero, which is this, right? And over here it is given that it is approximately 0.5. So over here the voltage, it will be 0.5 volt. Now coming to the second last question, over here it is given, this question is given and it is mentioned that the voltage dependent source 5 times as large as this, which is mentioned already over here, for VR is equals to 10 and Vx equals to 2, determine the power absorbed by each element. Power absorbed by each element. So since it is this is the current source, it means the value of I, it is 5 Vx, and it is given that Vx is 2, so the current is 10 ampere, right? And this 10 ampere, it is flowing in this direction, it is flowing over here, and it is flowing over here. We know it is given VR is 10, so VR is 10 volt. Now we need to determine the power absorbed, means we need to determine that we need to check power for this, it will be V into 10. Vx is given as 2, so the power will be 20 volt. Now we need to check whether it is going to absorb or supply. Since current is leaving the positive terminal, so it means it is the supplier, because absorber, it will be absorber if current is entering the positive terminal. So since it is leaving, so we will put minus sign. So this power absorbed is minus 20 watt. For this element, again the power is V into I, which is 100 watt, and over here since the current is entering this positive terminal, so it is positive. For this case, this is given as minus, this is positive, so the power for this, it is P equals to 8 watt into 10, it is 80. And now since the current is entering the negative terminal, so again it is the supplier, so it is minus 80 watt, right? So these are the answer. Now we have second part, is the element A likely a passive or the active source? Now since this is absorbing the power, so it is going to be the passive source. Okay, so we have one more question, last question. So over here it is given that the dependent source in the circuit, this circuit, a voltage, there is a dependent source in the circuit, provide a voltage whose value depend on the current Ix. So we have the dependent voltage source, which is this, and its value is depending on Ix. What value of Ix is required for the dependent source to be supplied 1 watt? So to supply 1 watt, what we need? We need that the current should leave. We want first of all, or over here, power supplied is 1 volt. So if we look at this over here, the current is Ix, right? The power across it, it is minus 2Ix. So if I calculate the power, it is, or before doing this, I need to change the sign. I need to put it as minus plus, and with minus plus I will put it as Ix. Why? Because over here negative voltage is given, and negative voltage means that we can redraw it in this way, right? Means minus sign is above, and if minus sign is above, so it means minus plus, and it is 2Ix, right? it means now the current is entering the negative terminal. So it, from the circuit it seems that the current is entering the positive terminal, but in actual it is entering the negative terminal because the voltage is given as minus 2ix. So once we put it as 2ix and the current is ix, now the power 2ix into ix, now it is going to be the supply, power supplied, right? So power supplied, we get 2ix square, and now it is asking that what should be the value of ix if power supplied is 1. So 1, right? So 2ix square is equals to 1, ix is equals to 1 by 2, and 1 by ix square is 1 by 2, ix is 1 by root 2, or we can write it as root 2 upon 2, or we can write it as root 2 is 1.41 upon 2, so 0.705 ampere. So this is the value of ix to get the power supplied as 1 watt. So these are some of the questions from the book Hayt and Kemmerly. So I hope that I am able to solve the queries. If you have any doubt, you can put it in the comment box, and do subscribe my channel and stay tuned with me. Thank you.